One, two, three.
What's up, team? Today we're talking quadratics. Short introduction. Today we're going to talk about how to create a quadratic given an a, b, and a c value, and then how to evaluate it and what a graph may look like. So first of all, this is what a general quadratic looks like. We have ax squared plus bx plus c, where a, b, and c are all real numbers. The key defining feature of a quadratic is that the highest power in the quadratic, meaning the highest exponent we have, is a 2. If you have anything greater than a 2, it is not a quadratic. If the highest power is less than 2, it's not a quadratic. The highest power must be 2. And then we refer to these values a, b, and c. Those are common terms. These are things we're going to have to know. So, for example, this question here says, create a quadratic expression with an a value of 1, a b value of -2, and a c value of 1. So to do this, all we need to do is plug our a, b, and c in where we see a, b, and c. So this one says we have an a value of 1, so we're going to have 1x squared plus our b value here. Our b value is -2, so we're going to plug in -2 for b, and our c value is also 1, so we're going to add that piece. Okay, we can clean this up just a touch because it's weird to add a negative, and this 1 is extra information we don't necessarily need. So our quadratic is x squared minus 2x plus 1. So we've created a quadratic with a given a, b, and c value. Sweet, we're done with that piece of the puzzle. Next, it says use this expression to create a table of values for x values -1, 0, 1, 2, and 3, and then sketch a graph of these values. So we're going to create a little t-table here, x, y table, and it says we're going to plug in -1, 0, 1, 2, and 3. So we have 5 x values that we're going to work with, and we're going to slowly and carefully plug all these values in to our expression and end up seeing what we get. I suppose I could have written this a little bit differently. I could have called this an equation, said y equals. This way our table makes a little bit more sense. Okay, let's plug each of these pieces in. We'll start with the -1 into this expression here. That means we're going to substitute -1 in for each of our x values here. So to do that, we're going to say that -1 squared minus 2 times -1 plus 1. And then we'll evaluate to get our y. -1 times -1 is +1. -2 times -1 would be +2. And then we have this extra 1 over here. 1 plus 2 plus 1, that's 4. Okay, let's do the same thing. Plug in 0 in. So we're going to have 0 squared. It's got plugged in 0 minus 2 times 0 plus 1. 0 squared is 0. 2 times 0 is 0. So we have 0 minus 0, 0, plus 1 is 1. Sweet. Let's clear some space. We'll do the same thing with the positive numbers now, 1, 2, and 3. If we plug in 1, we get 1 squared minus 2 times 1 plus 1. 1 squared is 1. Minus 2 times 1, well, that's minus 2, and then this constant is always just there. 1 minus 2 is -1. -1 plus 1, that's 0. Now we'll plug in positive 2. 2 squared minus 2 times 2 plus 1. 2 squared, that's 4. Minus 2 times 2, that's also 4. Interesting, but that minus there, that's key. And then the constant is still there. 4 minus 4, that's 0. 0 plus 1, 1. Last one here. We're going to plug in positive 3. So this one's going to be 3 squared minus 2 times 3 plus 1. 3 squared, that's 9er, minus 2 times 3, that's minus 6 plus 1. 3 minus 6, that is positive 3. Positive 3 plus 1, that's 4. Check this cool pattern that's been created. We go from 4 to 1 to 0 to 1 to 4. It's symmetrical. Kind of the middle point is here at 1, 0, and then the y values go up to 1, then they both go up to 4. Every single quadratic is going to have a pattern like this. Sometimes it might be hard to find the middle value, I guess, as these numbers grow larger. But there's always going to be some sort of middle value, and on both sides, it's going to grow in the same fashion. It's going to be symmetric like this. So let's attack the second part of what's requested here. It says sketch a graph of these values. I'm going to move to this blank space on the board. I'm going to sketch a Cartesian plane real quick. It looks like we need to have x values from -1 to 3, so we don't even need that many. 1, 2, 3, 4, and we'll go down to -2 here. And then for the y values, we go from 0 to +4, so we don't even really need the negative stuff over here. 1, 2, 3, 4, 5. There we go. So everything we're doing is going to be up in this section here. So this first one, -1, +4. Go to -1 on the x's, 1, 2, 3, +4 on the y's. That's our first point. Then we're at 0, 1. The next one is at 1, 0, so that's 1 on the x, and then it doesn't go up at all, stays down here. 2, 1, 2 on the x's, up 1 on the y's, and 3, 4. 1, 2, 3, 1, 2, 3, 4. That one goes up here. Check out this cool shape that is created when we connect our dots. This one goes up like this, and this one goes up like this. And it creates this kind of U smiley face type shape. This shape here, we refer to it as a parabola. So every quadratic, not only are the y values going to be symmetric like this, but because they're symmetric like this, they create a cool shape. Again, it's that parabola shape where they go in the same direction. They grow at the same rate on both sides. You'll see in the future, sometimes they point down, sometimes they point left and right. But in general sense, they are going to point up like this. This is mostly what you're going to see. We're also going to explore some that point down in the near future as well, and we'll show you how and why that takes place. Okay, today's practice problems. You're going to have to evaluate something like this, create a little table, sketch a little graph. Clearly does not have to be fancy. You saw how quickly that went. And then you're going to be asked to identify some different quadratics. What's going to be hand you an expression and say, is this a quadratic? Yes or no, and explain why. Well, the way to identify whether an expression is a quadratic is by looking at the highest exponent attached to an x, or whatever the variable may be. Generally, it's going to be x. So this one is indeed a quadratic because the highest power is 2. If you were given something like 3x to the third power plus 3x squared minus, 11x plus 4, this is not a quadratic because there's an x to the third power. If you took that away, now it's a quadratic because the highest power is 2. Well, what if you took that away? Now it's no longer a quadratic because the highest power is no longer 2. So just pay extra close attention to the highest power you have attached to a variable, and that will lead you to whether or not the thing is a quadratic or not a quadratic. Okay, go ahead and dive into these practice problems. Let me know if you have questions. You got this.